We're going to talk about complex numbers and quadratic equations today. Quiz 1, your take-home quiz 1 is due today. Please put it in the folder before you go. And then the next thing that's coming up is going to be test 1, which is not next week, but the week after. So Monday the 22nd. And next week, as that test gets closer, I'll tell you more about what it's going to be like and how to prepare. But let me tell you right now, before we start our lesson, at the very end of every packet that I give you is a study guide for the test that packet covers. Okay, so see, I'm on page 40 right now. Okay. If you go to the end of this packet, to page 51, there's a study guide for test 1. Okay, so just be aware, I know it's a long weekend and you're going to be really missing class on Monday and you're going to want some math to do. You have a study guide for the test that you can look at to get your fix. Okay. All right, so let's start with the teaching demo. People seemed pretty okay with the preview exercises. And if you weren't, we're going to go over some of these, some of the tools that you need to do this in the lesson anyway. So the first thing we're going to talk about is complex numbers. And up until this point in your mathematical life, you have been told that you can't take the square root of a negative number. You may have seen this before, maybe not, but if you haven't, you may have heard that you can't take the square root of a negative number. Today, we're going to start doing that. We're going to take square roots of negative numbers, and we're just saying, like, there is no real number. There's no number on the number line that we can think of that when you square it, you'd get a negative. Because if you take a positive number and you square it, you get a positive number. If you take a negative number and you square it, you also get a positive number. There's no real number you could square and get a negative. So we're just going to make up a brand new kind of number that does not live on the real number line. Brand new kind of number that represents the square root of a negative 1. And we're going to call it I for imaginary. Just imagine that this thing exists. I know it's weird, right? But we're just going to imagine that you can take the square root of a negative, and we're going to call it I. So if you want to take the square root of any negative number, break it up into the square root of negative 1 times the square root of the number, and then the square root of the negative 1 becomes an I. So for example, if I want to take the square root of negative 49, break that into the square root of negative 1 times the square root of positive 49. Square root of negative 1 is I, and the square root of 49 is 7, so this becomes 7I. Square root of negative 8. So I'm going to break this up into the square root of negative 1 times the square root of 8. Square root of negative 1 is I. And what's the square root of 8? 2 square roots of 2. Yeah, because you ask yourself, you're like, okay, is there a number that I could square and get 8? No. Right. But you could, there is a number, okay, there is a cube root of 8, but we're doing the square root, yep. But there is a number that divides into 8 that has a perfect square root, right? So this is going to become square root of negative 1 times square root of 4 times square root of 2. And then finally, square root of 4 is 2. So this becomes 2 square roots of 2I. And typically you put the I at the end because we're used to putting letters like variables at the end. Okay. And it's allowed because you can do multiplication in any order. Doesn't matter because you can do multiplication in any order you want. You could write 2I square root of 2 and it would be the same thing. Yep. Yep. All right, I squared. So let's look at the equation I equals the square root of negative 1. That's the definition of the number I. what happens if I square both sides of this equation? Okay, on the left, I get I squared. What happens when you square a square root? They undo each other, right? So all I'm left with is what's under the radical, which is -1. So I squared is -1, and this is super important, okay? We're going to use that little fact a lot. I squared equals -1. Because the square and the square root just cancel each other. You don't have to do anything to the -1. Yep. Okay. Okay. So when you're working with imaginary numbers, negatives under square roots, okay, we should write all your radicals in terms of I before you do any operations. Okay, so before I actually try to multiply these, I need to change root -20 and root -5 so that they have i's in them and not negatives. So I've got root -20 times root -5. So I'm going to rewrite root -20 as the square root of -1 times the square root of 20. And then I'm multiplying that by the square root of -1 times the square root of 5. Take your square root of -1s and make them what? I. Okay. So I have I times the square root of 20 times I times the square root of 5. And so I have an I times an I, which is I squared. Okay, so I have I squared. And then root 20 times root 5, root 100. Yep, that's allowed, so that's root 100. Okay. What's I squared equal? -1. We just talked about that in the last example. Square root of 100 is 10. -1 times 10 is -10. So the key there is that you should start, before you do any operations, multiplication, addition, anything, get rid of the negatives under the radicals. Bring in some i's first. Okay, so the next piece of today's lesson, moving on from complex numbers, imaginary numbers, is quadratic equations. And don't worry, the i's will come back. But we're going to talk about quadratic equations. So a linear equation is also known as a first-degree equation, which means that the exponents on the x's are 1s, right? We don't typically write them because x to the first is just x. Quadratic equations are second-degree equations, which means that the highest power you'll see on an x is a 2. These are also called second degree. Highest power on x in both of those equations is a 2. So the general quadratic equation has a form ax squared plus bx plus c equals 0. A, b, and c are real numbers. A is not 0. You should be pretty familiar with techniques used to solve linear equations. We're going to look at some ways to solve quadratic equations. You may or may not have seen, I'm going to show you 3 techniques. You probably have seen at least 1 or 2 of them. So the first technique involves solving a quadratic in the form ax squared equals c, or some stuff squared equals c. Okay, so let's take a look at solving x squared equals -25. So we've got some stuff squared equals a number. Okay, x squared equals a number. How do you undo squaring something? Square root. So I've got an x squared on the left. I would like to have just a plain old x, so to undo the squaring, I square root. And then what is the square root of x squared? Yep, x. And then I need a number that I can square to make negative 25. We couldn't until 5 minutes ago. Yeah, we can use the I, right? So what is it, Anna? 5i. Yep. Or also negative 5i would also work. Yeah, when you take the square root of both sides, you always have to write the plus or minus on the number, because there are actually two ways that you can get negative 25 by squaring. If I do 5i and square it, I get 25i squared, which is 25 times negative 1, which is negative 25, right? So 5i is definitely a solution. What happens when we do negative 5i? Well, negative 5 squared is 25. I squared is I squared, and you also get the exact same thing, negative 25. So there's actually two solutions. Nope. Anytime you're taking the square root of both sides. Yep. All right, so that's one technique. Take the square root of both sides and figure out what x is. Okay, so my next technique for solving quadratics involves factoring and using the zero product property. So the zero product property says that if you multiply two quantities together and get an answer of 0, at least one of your two quantities, one or both, was 0, right? The only way you can get the answer to a multiplication problem to be 0 is if one of your factors was 0. At least one or both. So we can use factoring of quadratics to help us solve quadratic equations. So because this is the zero product property, one side of my equation has to be 0 in order to use it. So the first thing I'm going to do in number 7 here is move the 24 over. So I have x squared plus 11x plus 24 equals 0. And now I have to factor x squared plus 11x plus 24. So this is a skill you probably learned in a previous class. It takes a lot of practice to really get the hang of factoring. What factoring means is rewrite what's written here as a multiplication problem. I want to come up with two things that I can multiply together that multiply to x squared plus 11x plus 24. Great. X plus 3, x plus 8. And you can check it by multiplying them together. So you may have learned the word FOIL. You may have drawn boxes. Raise your hand if you know FOIL. Okay. Raise your hand if you learned to multiply using a box. Okay. So mostly we have FOIL. I'll do quickly. I'll show you both, but then I'll probably use FOIL going forward since most people know FOIL. Okay, so when you FOIL stands for first, outer, inner, last. So when you multiply the first terms, x and x, you get x squared first, and then outer, you multiply the x and the 8, so you get plus 8x. And then the inner terms, the 3 and the x, gives you plus 3x. And then the last 3 and the 8 gives you 24. And then when you combine your 8x and your 3x, you get the original 11x. So you can always check if your factoring is correct by remultiplying it together and seeing that you got the same thing. All right, let's just, we'll leave it at that. And then there we go. Okay, so the purpose of the factoring is so we can use the zero product property. I now have a multiplication problem whose answer is 0, which means that the only way I could get the answer of 0 is if one or both of the factors were 0. And so then you just solve each of these equations separately, and we get -3 as one solution, and -8 is the other solution. Oh yeah, the box, right. So to multiply x plus 3 times x plus 8 using a box, make a 2 by 2 box. And we have x plus 3 and x plus 8. And then there are 4 boxes in your 2 by 2 box. And find the area of each box by multiplying the pieces that line up there. So here I have x times x gives me x squared. X times 8 gives me 8x. X times 3 gives me 3x. And 3 times 8 gives me 24. And then you combine all of your terms here. We have x squared plus 11x plus 24.
It's like a trick when you reverse it. You start with
The factoring part. Yes. Mm-hmm. We can go over that. X squared plus 11x plus 24. And I want to factor that, right? So there's a couple of methods that we can use for factoring. Many people just use trial and error, right? Where they just put down a double bubble and they go, okay, I need my first terms to multiply to x squared, so they've got to both be x's. And I know my last terms have to multiply to 24, so I could either have 8 and 3, 3 and 8, 6 and 4, 4 and 6, 12 and 2, 2 and 12. Are there any other numbers that multiply to 24? 1 and 24, yeah, thank you. 1 and 24, 24 and 1. And then you pick, and then you just check, right? And then you do your foiling with each possible one till you get an 11x in the middle. So that's the trial and error method. So with the 8 and the 3, you go x squared plus 3x plus 8x. Yeah, that gives me 11x. Oh, look, I got it on the first try. Anna.
So if I trial and error, you get 8, 3, then how is a problem? So like the other time solve.
Oh, okay, yeah, that's because I'm just doing the factoring part. So before, when I did the factoring, I still had plus 3 and plus 8, right? And then from that step, there's still another step, right, where you have to take each factor separately and set it equal to 0 and solve. Yeah. So this is the trial and error method of factoring. You just have to list out all the possible factors of 24 and then trial and error it until you get the middle terms, the outer and the inner terms to add up to 11x. So it's got to be the 8 and the 3. With the box method, right, we draw the 2 by 2 box. We put x squared in the upper left and we put 24 in the lower right. Okay, you always put the first term upper left and the constant term in the lower right. And then you say, okay, x squared times 24. You multiply those two terms together. X squared times 24, and you get 24x squared. And you start listing factors of 24. So it's similar to the trial and error method in that you have to list all the factors. So I have 8x, 3x, 6x, 4x, 12x, 2x, 1x, 24x. Like that. And then you want to pick the set that adds up to what? 11. Yeah, you want to pick the factors that add up to the middle term 11x. So I like those ones because they add up to 11. And that tells you what goes in these two boxes, 8x and 3x. Then from the top row, you factor out the GCF. What's the greatest common factor of x squared and 8x? X. Good. Okay, and then you say, what? Oh. No, Anthony said x, right? Yeah, okay. All right, x times what gives you x squared? X times what gives you 8x? 8, positive 8. And then x times what gives you 3x? Positive 3. And now we have x plus 8, x plus 3 show up on the sides of our box. You can use whatever method you know and love for factoring. I don't care. As long as you can get the factored form, whatever method you like is fine with me. All right, so let's jump to our third method for solving a quadratic equation. It's generally the most useful method of the three because you can use it even if you can't figure out how to do the factoring, right? Which is handy. Okay. So to solve an equation ax squared plus bx plus c equals 0, you use the quadratic formula. So we just have to identify what a, b, and c are, plug them into the formula. So in this case, what is a? 1. It's a coefficient on x squared. There's nothing there, so you assume there's a 1. And then what is b? Close. Negative 6. Yeah. The coefficient on the x is a negative 6. And c? Negative 7. Good. So then we plug into that formula. So I have x equals, that says the opposite of b. If b is negative 6, what's the opposite of that? 6. The opposite of b would be 6, plus or minus the square root of b squared, negative 6 squared, minus 4 times a times c, all over 2 times a. And then we just very carefully evaluate this following the order of operations. So I have 6 plus or minus the square root. What is negative 6 squared? 36. It's positive 36 because it means negative 6 times negative 6. So I get 36. Then I have negative 4 times 1 times negative 7. What does that come out to? Positive 28. A lot of mistakes happen there with the signs, so be careful. That's all over 2. Okay, then I have 6 plus or minus the square root, 36, 64, all over 2. And then plus or minus means you actually, well, actually, first we can take the square root of 64. What is that? 8. So this becomes 6 plus or minus 8 all over 2. And then the plus or minus means actually do both. Do 6 plus 8 divided by 2. Or 6 minus 8 divided by 2. So 6 plus 8 is 14 over 2 is 7. 6 minus 8 is negative 2 over 2 is negative 1. So that's the quadratic formula. Yeah. Oh, sorry, you're right. The roster method means that the solution would look like you put them in curly brackets and then you list them with a comma. Doesn't work? What do you mean?
You have to put them inside correctly in order for it to accept.
Yeah, that was super annoying.
Was that not fun? Yeah.
Hmm.